We're looking at tree diagrams. So a tree diagram is a way of representing the probability of a chain of events happening. So we start off at the beginning and we'll say, what is the probability of something happening here? So if I've got a container with black and blue objects, let's say the black is spiders and the blue are frogs. How many total objects have I got? I've got 5. So I know that the probability is out of 5 to start off with, and then there's 2 possible options. The first thing I draw is either going to be a frog or a spider. So we'll use blue for the frog, F for frog, black, S for spider. So from this point, what is the probability that I drew a spider out of this container? Well, how many spiders are there? There's 3. And how many total objects are there? There are 5. So there's a 3 in 5 probability, or 3 in 5 chance, that I'll draw a spider. If I was to look at the frogs, what's the probability I would draw a frog? There's only 2 of them, and there's still 5 objects. So this is my starting point. From here, I now look at this branch. If I drew a spider, I've taken the spider out in this case, it's not replacing. What is my option from this point? I can either draw a spider or a frog again. So let's say this is frog, this is spider. Now I look at what are the probabilities of these 2 branches. From this point, if I had a spider, well, there's 2 of them out of 4, so I would just call this a 2 in 4. The frog, exactly the same, 2 in 4. I can go once more. Let's say I drew the spider out the second time. Now I've still got 1 more spider, so I can still have another spider option, but I could also have a frog option. And now my probability for the spider is 1 in 3, and the probability for the frog is 2 in 3. However, at this point here, had I drawn my spider first, then drawn a frog, now I've still got the same 2 options. So from here, I can either go spider or frog. And I look at the individual probabilities. So for this one, to draw the spider, it's a 2 in 3. And for this frog, it's a 1 in 3. And I could go once more again. If I took this spider, I could do the same thing. If I took this frog, in this case, my only option now would be spider. So let's just stop there. If I drew a frog in my first draw, and let's move this down so we've got a bit more space. We said that was still a 2 in 5 chance originally. I've drawn a frog. Now what are my options? I can either draw a spider or I can draw another frog. We look at the probabilities along these branches. The spider is a 3 out of 4. The frog is a 1 out of 4. From there, I look at, well, if I took a spider out, I can still go spider frog. If I took a frog out, now I can only go spider. Still good to write the frog, even though in this chance probability is 0. In this case, if I took the frog, my spider is a 3 out of 3, or 1, which we'd expect, because a probability should always sum to 1 for any event. So here you notice there was a 2 in 3 probability I got the spider, and a 1 in 3 probability I got the frog. One of these has to happen. I can't draw anything else, which is what we talked about before, about a complement event. So they must sum to give me 1. The 2/3 plus a third gives me 3/3, or just 1. So this is a neater looking version of the diagram. I've got my probabilities of each event on the branches. So here I started with a spider, and the probability was 3 in 5. If I was to get another spider, the probability would be 2 out of 4. Because I've taken the spider out, I've now only got 4 objects left, and 2 of them are spiders. I can always check every branch because they should sum to give me 1. So here I've got 2 quarters and 2 quarters, gives me 1, perfect. 3 quarters and 1 quarter gives me 1. Here I've got 2/3 and 1/3, 1/3 and 2/3, 2/3, 1/3, 3/3, 0/3. So it always sums to 1. Each of these lines represents a step. So this is step 1. This is the first thing I drew. Then this line here is the second thing, and then the third thing. So I could keep going until I run out of objects. Sometimes you may only have 2 steps, sometimes you might have a lot more steps. And you can see that every time you go, it gets a lot bigger. So you need to give yourself enough space when you start off with. If I then wanted to write a question from this, I could say, what is the probability that I get a spider and then another spider? So we can write it this way, P of SS, where we talk about probability of S first and then S second. So you could write this as comma, or you could write a little then in there if you want. So probability of a spider, then a spider. But we can just write PSS, and that means this, then that. So probability of these. What is the probability of the first spider? It's 3 out of 5. Probability of the second spider, and I'll write this as second, was 2 out of 4. What do we do along the branch? In this case, we multiply, because from earlier sections we've seen that if we have a then statement, like the probability of getting a spider, then another spider, it's equal to probability of spider times probability of spider. So we multiply. So here, this question would be 3/5 times 2 quarters, which would give us 6/20. And we can simplify this down, and we generally would. This is 3/10. So we've got a 3 in 10 chance of drawing a spider first, and then drawing another spider. If we were then asked, what is the probability that I get a spider and a frog in 2 picks? If the order doesn't matter, I can go spider, then a frog. But if the order is not important, I could also get a frog and then a spider, and I would end up with the same thing. I would still end up with 1 spider and 1 frog. So if the order is not important, we can say, look at the chart, circle everything that suits what we want. So spider, frog, we've got spider, frog. Here I can take frog, spider. So there's actually 2 ways that I can get what I want. We look at the top half, just like we did before. Probability of spider, frog is probability of the spider times by probability of the frog. And that's going to be this, which is 3/5, times by the frog, which is 2 quarters, and that'll give me 6/20, or 3/10. That is option 1. Option 2 now, if I look at the second half of my branch, tells me that I can have probability of frog times the probability of the spider, because these aren't important. I don't care about the order. In this example, the frog was 2 out of 5, and I times it by the spider now, which is 3 out of 4, and that's going to give me 6/20 as well. So going along a branch for a probability, I multiply. Always. If I go along a branch, I multiply. If now I combine multiple branches, I say going along this branch gives me what I want, but then also going along this branch gives me what I want, means that I could get this, but I could also get this. So if we think of the very basic concept of probability, how many options are there? Well, there's a lot of different options, but how many possible combinations have I got? I've got 2. I've got this one and I've got this one. So in this case, I can add them together. So my total probability is actually going to be the chance from option 1 plus the chance from problem 2, which gives me this one, 3 out of 10 plus another 3 out of 10, which is 6 over 10 or 3 over 5. So going along branches, I multiply. If there's multiple options, so I can go along this branch or I can go along this branch, and they're both acceptable, I add them. So adding options, timesing options. What if I said something like, what is the probability of getting 2 spiders? Not necessarily a spider, then a spider, but just 2 spiders. So probability of 2 spiders. And you could write this a couple of different ways, but I just want to know probability of 2 spiders. So I'm going to write this as P of spider spider, but I'm not talking about spider first. I'm just saying by the time I get to the 3rd draw, what is the likelihood, the percentage, the chance that I end up with 2 spiders? Again, I just look at the tree diagram and I look for how many ways can I get 2 spiders. Well, here I draw a spider first and then I draw a spider. So that's definitely good. If I draw a spider here, then a frog, I can still then draw a spider. So this is another option. If I go here, then here, then here, I still have 2 spiders, so I don't really care. Here, then here, then here, I still have 2 spiders. So this doesn't really matter. This gives me what I want. Let's look at this option. Here I draw a frog first, but I can still draw a spider and then a spider. So this option is good. Here I drew a frog, then I drew another frog, so that's no good. There's no possible way I can do that. And I'll include these just to show that you've got all the options. So now I look at, what have I circled? Well, if I number these, I've got this one, this straight path here can be 1. This boomerang here can be 2. And if I went this way, this will be 3. Now I've only got one option, and this will be 4. So the probability from this question of ending up with 2 spiders would be probability of option 1, option 2, option 3, option 4. Now remember, when we go probability of option 1, which is this, we're going along the branch, so we're going to multiply. But then option 2 is a different branch. This one is a different branch. So I add option 2 to option 1. So I can write this as the probability of option 1 plus probability of option 2 plus probability of option 3 plus probability of option 4. And now I can just calculate these individually. So if I just do the first couple, probability of option 1. We look at, where does option 1 go? It goes 3/5. We're going along the branch, so I times by this one, which is 2/4. Going along the branch again, 1/3. So I look across the top, 3 times 2 times 1 is just 6. 5 times 4 is 20, times 3, 60. So 6 on 60, which is just 1 over 10. So there's a 1 in 10 chance. That was option 1. Probability of option 2 is, looking at this one, we still had 3/5. I'm going along the branch, so I times by 2/4. Going along the branch to this option, times by 2/3. That gives me 3 times 2 is 6, times 2 is 12, over 5 times 4 is 20 again, times by 3 is 60. So 12 over 60, or 6 over 30, 3 over 15, if we want to simplify it again, 1 over 5. So far, for my total answer, I need the probability of 1 plus the probability of 2. So this tells me that I would add this to this, and then I would do probability of 3 going this way, and then lastly this one. So far, the probability is going to be 1 over 10 plus 1 over 5 plus whatever probability of option 3 is, plus whatever the probability of option 4 is. And I add these, remembering that now we're adding fractions, they need a common denominator. I'll get an answer, and that is the probability of 2 spiders when the order is not important. If the order was important, this would be very different. It would look like what we saw before. If the order mattered, the only way we can get 2 spiders is to start with a spider and then get another spider. And that would be the option that we did before, and we've already calculated that. That's 6/20.